Microphone is on. We are hot. All good? You mean? You just see my screen? Beautiful. Oh, hopefully no one's going to boo me.
Maybe. Yeah, I think so. But then it's like. Yeah, I think so.
Real good. I don't need a microphone, I can yell.
No, you don't.
Waiting for the video to work.
Oh, the video, is it working?
It's working.
Yeah.
So the HDMI.
HDMI?
What's that?
Can I grab the HDMI?
HDMI, yeah. Oh, can you better mute my mic?
Okay, that's pretty bright. Hello. Thank you for coming. Welcome, class. Sorry, you guys replied like you were kids. So, yeah, so welcome to Golang Syd. May 30th, right? So we don't use Twitter anymore. We use this guy or Mastodon. I've not bothered to set up a Mastodon instance. I've got a lot of things on to-do list, and you will see later, right? So interesting news about tonight's sponsors for food and drinks. We're sponsoring ourselves. And I think Katie will start by telling you why. Slide, please.
Okay, thanks, Stu. Yeah, hi everybody. Thank you very much for coming tonight. It's good to see you all again because it's been a while since I've seen you all at the meetup. So we've got sponsors for tonight for wonderful food, which it looks like it's enjoyed by everybody very quickly. Did you all enjoy it? Because it's they're actually Pilot on King, in case anyone doesn't know. It's a non-profit organisation that helps refugees when they arrive in the country to know what's expected when they join the workforce. And it's, I think, beautiful food, and I love what they represent. And I hope you enjoyed it. So that's Pilot on King. So our sponsors for the food is Go Get Matched. So this is what I'm quite excited about, because some of you might know that my previous life, I was a tech recruiter most years ago, and I am no longer in recruitment. However, I've got this startup that I'm working on, which is in the early stages, and Go Get Matched is where we're going to streamline the interview process. So imagine speed dating. Has anyone been speed dating before? No comments. Oh, very good. Yeah, so it's going to be something like that. Imagine, 10 Go engineers who are open to hearing about new opportunities, about different Go engineering teams, and on the other side, people who are hiring and having a conversation. And it's just going to be a complete streamlined process versus the weeks upon weeks of the interviews that I'm sure you've all been through before. So if this is something that interests you, then I'd absolutely love for you to take a quick snapshot of the QR code and just let me know, just pop through your details so that I can just get a feel for if this is something that you guys might want to get involved with. Yeah, I really appreciate that. So thank you very much. Let's go get matched.
The other sponsor is GovCon.au, and we're in a very experimental mood with GovCon.au right now. So yeah, this came out as a brain fart, but yeah. So there's this thing called go 5 times, right? But if you're Japanese, you would say something along the lines of go no by, which means 5 times of go. Hence, go, casa. And what it is basically, we're trying to plan and experiment with our logistics for GovCon.au. So this is basically a retreat, a week-long retreat. Developers go there, work on a few set group of like 4 or 5 projects, and every night we present to each other what we've done. And not in a sort of stand-up way. It's like, hey, I did this cool thing, I learned this cool thing. Right. The other go is that's one go, right? The first go is a verb. The second go is a noun go, the Go programming language. The third go is, well, in your downtime you play Go. Hence a go for Meetup, Go stones on Go board. And of course the last 2 goes like dancing.
Or if you only use 4 to go.
Well, if you don't know how to go, play Go, we'll teach you how to play Go, but you are expected to know how to code in Go. If you do not know how to dance at Go dance, well, we'll learn Go. And so, yeah, so again, we're experimenting with formats like this could be something that we might run for GovCon New Zealand, because New Zealand is a very nice place, but in order to know if this would even work, we will have to experiment in smaller scales, and that's what this is all about. If you're interested in going for a retreat where with a bunch of people that are smarter than me, that's the link. And now, without further ado, let's bring our first speaker.
Before we do that,
yes,
I just want to say a massive thank you to Helix, especially Gary, who's really pulled it out the bag for us tonight. I actually want to have a round of applause because you're actually sitting on came from Gary tonight. He's driven them over in his car, so you've gone above and beyond and just say great. Thank you. Okay, I think that we can now introduce our first speaker for the evening. So we've now got Aaron. Thank you.
Thanks. And I need to do beautiful. Everyone see that? Awesome. All right, so this is something a little bit different. My name is Aaron Sajkowski. I'm a former Microsoft Cloud Solution Architect and engineer, and don't hate me. I've left, I've seen the light. So I'm a platform and software engineer. I'll give you a bit of an intro about myself. So I used to be an Azure technical trainer. I've done a lot of Azure stuff. I've been in the IT industry for about 30 odd years. There's my LinkedIn profile if you want to connect with me and abuse me. I've been doing Azure for about 10 years, so a lot of big Azure deployments. I'm a platform engineer, infrastructure as code, deployments, and also CLI tools. So Azure is really good for that. Now, what's really weird is Microsoft have embraced Go and Rust a lot. You probably read about this a little bit. You have no idea how much Go Microsoft is actually writing. A lot of their tools that you may or may not use day to day, CLI tools, are all written in Go. Weirdly enough, they don't do .NET for this sort of stuff. Reason being is self-contained binaries and all that kind of stuff. So yeah, and we'll talk about the Golang Academy a little bit later, but this is something we're looking at doing, launching some Go training in Australia for people who are interested in getting up to speed with Go. And we're sort of formulating a way of doing that. So me being a former trainer, hopefully you can bring my experience as well as Nick and Katie to be able to deliver that for us. So watch this space. Cool. So you feel free to hassle me on LinkedIn or email me if you've got any questions. So I thought I'd make this interesting as much as I can as far as integrating Go and Azure. You're probably thinking, well, there's all these SDKs and all this sort of stuff. Now, what's the reason being is why would I want to use Go with Azure? Well, obviously Go, the reason we're here, it's a good language, easy to learn. The one thing about this is the SDKs that Microsoft produces are absolutely first class. This is not being biased, they're actually very, very good. Now they support all the major languages. So you've got Python, obviously JavaScript, TypeScript, Rust is coming-ish, kind of. They're working on it. I've heard that because AWS have got one, and I know Microsoft are actually doing one as well, just to keep up with the Joneses. But the tooling and the Go support is absolutely first class. You can do some production-ready Go code using these SDKs with no worry, and it is supported by Microsoft too. So if there's an issue, raise a bug request, they will fix it. They're on it. So obviously, we all know Go is great for API development. It's a statically typed compile language. I'm preaching the converted here. What's really nice about this is I've used Python before, and I've done a similar talk on this in Python. I'm not using Python ever again. I'm sorry. I'm over it. The problem with it is the dependencies are a nightmare. When you start doing stuff with Python and anything beyond like a hello world script, the dependencies is gigantic, and you've got to use things like people nodding. You've got to use tools like poetry and all this other stuff, and it's just mental. Yeah, so the thing is about using Go, which is really good for what I do, is CLI-based tools. It's a single binary. You ship a single executable, and I've written quite a few tools using the SDK, using the management APIs and the client APIs, single binary. That's all you need to ship. None of this other shenanigans with third parties and all this other stuff. So it makes it really easy. Obviously, it's got great concurrency, and obviously Go's got a pretty cool little logo. You can sell that to the business. I don't know what business value that has, but anyway. So the Go SDK, what is it? So it allows me to communicate to base Azure services. So what they've gone and done, the product team inside Microsoft, is use a tool called AutoMapper to go and retrofit and reactively go in and look at all the APIs and created a whole bunch of wrappers in native languages. And what they've also done is brought first-class service support to all the different services in Azure. So there's about 180 plus SDK libraries you can integrate with. So who's familiar with Azure, by the way? I'm not talking to who's used Azure. Okay. So people know what I'm talking about with resources, storage accounts, resource groups, that kind of thing. Who's AWS? Same sort. Come on. Any Google people? GCP? Any Unisuper people? Too soon? All right. So what's really nice is Microsoft's done a really good job. And I'm not promoting this in any way. I'm a former Microsoft. I can say this now. I'm not under an NDA or anything, but they've done a very good job of this, and they've seen what the industry is doing, and they've created SDKs to be able to use your language of choice to go and talk to the Azure services. So you could use Python if you wanted to. I don't know why you would, but you can. I'm with you. Yeah. So you can do it in C#, you can do it in Java, .NET. What doesn't really matter, but the SDKs are first class. Now, the SDKs themselves are basically think of them as like a wrapper for the APIs, but it's a little bit more than that. They actually do quite a bit of smarts. And all the SDKs are open source. So if you go and use an SDK using Go, trying to connect to Azure, and you find a bug, raise a bug request, they'll get onto it. They'll actually go in and you'll get a response from a Microsoft engineer helping you to triage it. They're actually pretty good. They're very active. So it's under active development. Okay, any questions on that? Interrupt me at any time with any questions you might have on some of this stuff. I won't go too quick. It's a reasonably short talk. Now, for those who don't know how Azure works, this is how Azure works under the covers. It's a bunch of APIs. You can sort of see down there called a thing called Azure Resource Manager. So this is a very good slide. When I used to teach Azure courses, this is one of the main slides we used to tell the students to understand. So when you think of Azure, AWS, I'm sure, is the same. It's really just a bunch of APIs under the covers, right, to create resources and things like that. So you'll see there's authentication. So that used to be Azure Active Directory. Now it's called Entra ID or something like that. So when I log into Azure, when I authenticate to Azure, it uses that identity provider to go in and talk to those APIs via the resource manager. So you'll see on that diagram in the bottom left, sorry, I'm pointing if you can't see, it says SDKs. That is what Go is talking to. The SDK is talking to Azure Resource Manager to talk to what they call the control plane. So when I go in and create a resource in Azure, say a storage account, a resource group, whatever, it's using the control plane to go and call the API. I've authenticated using my credential to go in and create that resource. That's how it works. Azure is pretty straightforward once you get the hang of it. This is like not really deep dive, but that's basically how Azure is put together. A bunch of APIs you can call from your programming language of choice. I won't worry about too much one at the top left there. That just talks about, the Azure structure, resource groups, subscriptions, and things like that. But when you log into Azure using the SDKs, you're authenticating to Azure Active Directory, now known as Entra, to go and do what you need to do. Now, as I said, the tooling is pretty good. I can share these slides with you guys if you want them as well. There's nothing too sort of super secret in here. You go install a bunch of API packages, go get GitHub, So you've got AZ Core, identity, resources, and subscription. Pretty straightforward. And the documentation, I will say, is very, very good. Microsoft is actually quite good with their documentation when it comes to this sort of stuff. Their SDKs and all that is actually quite good. So when you're using the SDK, it's important to understand you need to authenticate to the service using Entra ID, right? So Azure AD, let's just call it that because that's what everybody knows it as. I don't know why they changed it, but anyway, what it's called now. What's important is when you're authenticating to any of the services using some code in Go, you need to use this thing called the default Azure credential. This is actually really cool because you don't have to worry about doing anything with managed identities or swapping identities, any of that sort of shenanigans. It does it for you. So I can use one authentication provider via the SDK to authenticate to my servers, create a client to say Cosmos DB, which now has first-class support as well. Using the credentials that are passed into me, I can log in via the CLI. I can use the managed identity or a service principal. This will all do it for me. I don't have to change the code. Once I've deployed it, that's it. It's all done for me. It's pretty good. It's a really smart way of handling credentials and authentication. In the old days, you had to use all these Active Directory 8L libraries and all this other stuff. It was pretty messy. This just does it for you. It's basically like one line of code to get the credential. I've shortened the code a little bit just to make it more readable on the screen. Any questions on that? Does it make sense? Pretty straightforward. It's very clean. It allows you to write really nice, clean code. It's not really rocket science once you get into it. It's standard Go. You're just talking to Azure resources. I've authenticated using the credential provider there. Get the credential, pass it into my new client. I'm creating a client here for a Cosmos DB database. Connect to it using that credential. Pretty simple. So where things get a bit interesting is here. This is what I'm doing here. This is a bit of boilerplate code. Forgive me. It's not quite 100% right. I wouldn't write it this way, but this is sort of, I've ripped this off from one of the samples just to show you, this is creating what they call a resource group. So what we're doing in here, passing in a context, we're using standard Go semantics here to go and create our resource group, passing in a context. And you can see here, we're going to get a return back of ARM resources resource group pointer. So we're creating a resource group and telling it to create or update. So for those that don't know what a resource group is in Azure, it's just a container to put resources in. That's it. You've got virtual machines, storage, things like that. You put it into a resource group. It's a container. It's just a really simple construct for containing your resources. So all I'm doing is saying create a resource group, tell it to put it into a location, and when it finishes, return me a resource group out. That's it. Pretty straightforward. But the main thing, let's go back a slide, is this guy. Default is your credential. That's very important. So I've authenticated using the Azure CLI on the command line, got my credential token, and then I can run my CLI tool using that credential, passing it to this guy, and it handles all the heavy lifting for me. It's pretty good.
GCP doesn't even require you to do that.
Doesn't it? It reads your mind.
It looks in special directories.
No, but what it does, it just deletes your stuff. Again, too soon. Sorry, I'm not going to let that go. Okay, yeah, it probably does it a little bit differently, but ultimately this is how it does it. So I'm assuming that the AWS SDK is something similar. I've not used it, but I'm assuming it's something similar. It's all API based. You authenticate, you pass your credentials to it. I do the operation. Now, what's important to note here, it's got my credential back from this guy. Now, if I don't have permission to go and create a resource group, it will throw an error saying access denied, which is by design because I don't have permission inside that construct with that context to go and create that resource group. If I can't do it, it'll just say, you don't have access. It'll likely give me a nasty error saying access denied. That's how it works. I mean, you can trap the error if you want, but it's pretty straightforward to do that. I'll show you a demo in a second. Some of the things I've learned with doing stuff with Go and the SDK and all that sort of stuff. So who still here uses make files? Stop doing it. Use task file. You'll thank me later. It's awesome. Have a look at taskfile.dev. It'll change your life. Sorry? Task.
There's also
Just file. Okay, there's a few around, but task file I've recently discovered. It's like I've just discovered some new toy. It's awesome. So the thing is too, what you want to do is make sure your dependencies are kept updated. So you can write yourself a little task file script. I've got one on my GIST if you want. It allows you to do that. Keep all your dependencies updated. And you don't want to make your project too sort of crazy. I've seen some weird ass, clean code sort of things online where they make this really convoluted project structure. When you start doing stuff with the SDK, don't fall into that trap. Keep it simple as much as you can. So there's standard project Golang layout. Stick with that to start with. Don't go too crazy with it. And obviously you can use the standard tools like formats and other things like that. And another second one I've discovered recently, I was talking to Nick about this, is this new thing where you can embed version using embedding inside your CLI tools using GoGenerate. I'll talk to you afterwards if you want to show you how to do it. I've just discovered this recently too. So you don't have to inject the build numbers when I do Go build anymore. It does it for you, pulling the Git tags out automatically. It's very nice.
You can do that with the command line. It's just a flag.
Yeah, it's just a flag. Yeah, this just does it automatically via a shell script. It's pretty nice. I've just discovered this recently. So
if you don't have Go releaser on that list, you need Go releaser.
I've got, Go release is good too. I've got a thing for that. And also too, logging framework, Docker init can now generate Go Docker files, which is good. I don't know if you knew this. Yep.
Question from the peanut gallery.
The peanut gallery.
Why Zerolog OAuth versus Zap or Slog?
I've used Zerolog because it's got zero cost abstractions. There's very little overhead with it. I've used it a little bit. It's quite good. I'm sure there's other ones. There's logging. There's frameworks for everything these days. So one of the things I like too with Docker now, the newer versions of Docker is you can Docker init. I don't know if you've seen this. It'll actually generate Docker files for you using best practices. So you run Docker init, point it at your project. It goes and analyzes your project and creates a Docker file for you. It's pretty nice. It's something new I've discovered too. All these new toys. And obviously use web. There's a big conversation now with web frameworks. Use which one ever makes sense to you. Personally, I'm an Echo fan. Whatever works. Doesn't really matter. Pick one, stick with it, go with it. Yeah.
Does the Azure SDK have like interface only packages for like testing or mocking?
It does have some. It's got, the question is, does the Golang SDK for Azure have interfaces for testing and mocking? It's got some. I haven't actually looked at that, but there are some stubs and stuff you can do tests with it. They've actually got their own testing framework. It's actually really solid how they've done it. It's like production grade code. It's very nice how they've done it.
Yeah, it's a storage method, so you can
Mock them, stub them, and mock them. Yeah, they've done a pretty nice job of it actually. It's quite nice.
How much protobuf shuffling do you have to do with the Azure stuff?
How much?
Protobuf shuffling.
Protobuf, none. I mean, you can do it. You can do. The question is, how much proto-buffing do you have to do?
If you want to interact with Azure, right? The SDK wraps everything, right?
It wraps everything. Yeah. So there's no. You don't have to talk to the Azure APIs at all. You can. I've done that and I've played around with it. I'm like, I don't need to do that. It's all wrapped for me. So I need to do some stuff with the management interfaces and stuff like that. I just use the SDK instead of writing this much code. I write like one line. I'm like, I'll save myself like days of work. I think it's protobuf. Yeah.
Yeah. So in GCP, everything you do, you can shove protobuf around.
Sorry?
You shove protobuf around.
Oh, really? Okay, I didn't know that.
Yes, they're part of Larry's
Protobuf shoveling thing. Yeah, you don't have to do any of that. So yeah.
I was going to say you can change the transport. If you change the transport in the SDK, you got it.
Inside the Go. Yeah, I haven't tried. I've just used the standard APIs. It just works. And they've got, what's really nice is they've got all the Go routines and everything all wrapped up nicely for you. So when you do, some things I found, when you do certain calls, it returns you like a poller object. And you can query the poll to see if you're doing a long running operation, it actually returns you a polling interface. You can query that and see how long the operation is going to take. And you can keep querying that. It's really nice how they've done it. It took me a little while to get my head around some of it, but it's really nice how they've done it. What's that? Yeah.
So you never do async stuff. You have to shove into a routine. I wish they had a call.
Interestingly enough, I started messing around with Go routines in the SDK. I made it worse. I'm like, what am I doing? And I thought I sent myself down a bit of a rabbit hole. I'm like, it actually performed worse when I put it in a Go routine because I think they wrap. I looked at the code and the code's all available. They're actually doing a lot of that for you. Yeah. So I'll show you a little sample in a minute. So here's some things for you to take away. when you're developing. You can take a shot of this. I'll share these slides around. These are some useful tools. Obviously, the Go SDK. One of my new favorite tools is this thing called Go Blueprint. If you haven't looked at that, check that out by a guy called Melky, who works at Twitch. Very slick little boilerplate generator. There's all these frameworks, Go releases up there. You've got Air. If you're going to do any sort of API development, highly recommend installing Air. It allows you to do hot reload of your APIs without having to reload everything each time. I used to be a .NET developer, and .NET's had this for a long time. So this is something in Go, you can do this. And I think you can do this in Rust as well now. There's JSON to Go, Go Playground, Awesome. Awesome Go is actually a really good one. There's a lot of really nice resources there. So if you find something that you need to go and use, don't build it yourself. Go to Awesome Go and find it. There's APIs or packages for machine learning and all sorts of cool stuff there. So I highly recommend that. You can also build Azure functions with Go. They're not really first-class citizens though yet. They're talking about making those properly compiled first-class citizens. Right now, they're using a HTTP handler, so they're a bit iffy how they've done it. Not like AWS Lambdas. They're more performant. Yeah, Taskfile, highly recommend checking that out. That's the business. And there's also the standard Go project layout. So if you want to, set up a basic project layout, start with the standard Go layout. I started looking at clean architectures and all this other stuff, and I started going mad. Hexagonal architectures, and I'm like, what am I doing? So I reevaluated my life and went to the standard project layout just to make sure I'm back on track. And obviously Cobra. I played around a little bit with Cobra. For what I was doing, it's a little bit too complex for what I was doing. It's good, but it's what I was doing is quite complex. I'm going to look at it again. I just haven't had time to really mess around with it too much. What's that?
We'll show you some magic.
I've looked at it. I just haven't had time to really.
Not Cobra.
Oh, not Cobra. Okay, I haven't looked at that. Yeah.
Yeah.
I've just used. There's a couple of ones I've used that just do standard argument parsing and that, and it works for what I was doing. But I need something a bit more solid. Yep. So what I'll do, I'll show you. It's not really a demo. I'll just show you what this sort of looks like. So obviously, I'll show you this. I mean, I won't run this, but it's really straightforward. It's just standard Go code. Oh, if you can see it, you can't see that. Okay. Can you see that? No, you can't see that because I'm running PowerPoint full screen.
Depends what you share.
Right, now you can see it. So don't destroy me for this code, but I tried to make this as clean as I can. So I'll zoom in a bit more. So pretty straightforward stuff. I'm just reading in a subscription ID, and all I'm doing here is, you can see I'm creating a context, standard Go sort of processing. I'm passing that context down the line so I can do cancels and things like that. Getting the default credential, checking if I'm logged in. So I need to actually be logged in into Azure via the CLI to be able to do that. So to log into Azure, I go AZ CLI and say login, get my credentials for the life of that, and do that. Now, if I want to do that in an automated way using like a service principal or a managed identity and the server side using AD, I can do that. I just have to change the way this code works here and just call it a little bit differently, but I don't have to change any of my functions. Get the resource group client, get a reference to it, create the resource group and print it out. It's pretty straightforward. It's not really that exciting, the code, but it's just showing what it does, and it's kind of clean. It's got failures and all that sort of stuff in errors, returning errors and things like that. Now I'll show you what the code looks like for create resource group really quickly. You can see here, it's a little bit of a wrapper for some of this code. So it's going to give me a bunch of stuff here. This is just some sample sort of stuff I'll put together really quickly. And it uses this tool. Another one that's really cool is Codium. I don't know if you've seen it. It's like a ChatGPT competitor, but it's free. Sorry, a Copilot, but it's free. It allows me to go and generate comments really nicely. So creates Go docs for me really nicely. Yeah, so it's kind of nice. And obviously the big one here is this auth library. So this is where it's actually doing the new default Azure credential, just returning that, pointer back to it. So it's very straightforward, just using the standard Go interfaces inside Azure SDK. And the thing about this, is really clean and it's really fast. So there's no interop or no marshalling or anything like that. I found it's actually very nice because they've made the interfaces very much first-class citizens. Yeah.
And so you're putting environmental variables for your access key and access token.
Yeah. Yeah. So I'm not hard coding those anywhere.
Yeah, that's what it's like.
You can do that. You can use what they call, so in the world of Azure, you have this thing called a managed identity, which is, as the name implies, it's a managed identity managed by Azure Active Directory. So there is no password, there is no login. I tell it the account I want to use, it goes and looks up that account, passes that reference in via a token into this, does exactly the same thing. I don't have to change any of this code to do that. It's really nice. There's a bunch of wrapper code in here. It's pretty sort of standard. It's not the most beautiful code you'll ever see, but it gets the job done, and it's fast and easy to maintain. So it's just a black box. I just go and create a resource group, go and create a resource group, go and create a VM. I can create a VM. But this is very sort of rudimentary stuff. If you want to do something a little bit more advanced, you have to use the management APIs. And that's a whole different kettle of fish. That's when you put your big jacket on and get ready for some battle with that one, because there's some serious stuff in there you want to do. So that's where you can interact with more of the management layer side of things inside Azure. It's very interesting what it does. And it's really, the documentation did my head in a little bit trying to work out what it's doing, particularly with the polling interfaces and stuff. But once you get a handle on it, you run a long-running job. It takes a while to go and query an API. You get a result back as a polar object. You can, as in polar, P-O-L-L-E-R. You can check the status of that long-running job to see when it's finished, and then run it in a loop and then check the status of it. Yep.
So these simple, like examples you've got here, are they 100% synchronous? So if you say get something, and then like it will not actually return until it has.
They're synchronous, but under the covers, it's also it's a bit of magic under the covers too. If you look at the code, they do a bit of both. And interestingly enough, I looked at some of the code for some of these. There's no Go routines anywhere. So if I wanted to do that, I can wrap these in a Go routine if I wanted to. Then I've got to pass in the channels. I started looking at and actually made it worse for some of them. So you can do it. These are synchronous from what I can tell. But if you want to make them asynchronous, you need to do Go routines. But you've got to make sure you use returns in the channels, also returns in the channels for errors, and as well wait groups.
Or simple stuff that like you're not going to say is production ready, this is fine for getting started.
Even production ready, this is fine. If I want to go log into Azure, go and create a resource group, I need to, I can't really do that asynchronously, because I need to go and create a resource group, wait till it goes and gets created, and then give me the result back. I can't just run it and then come back. I don't know if it's finished.
Well, that's if you get a polling object back, then check it.
Yeah, not all of them. These aren't really typically long-running operations. These are actually quite fast. The ones that are long-running are more of the management APIs. They take quite a while to run.
So this box in Azure, would that return immediately with like a I'm okay, but query it, you get a response?
That's where you get the polar. So you go and basically go and provision a VM. To be honest, I probably wouldn't provision VMs and resources this way. It's not the way I would do it. I'd use something like Terraform or something like that to do it, but it shows you can do it. It's using the same APIs as Terraform and all those guys are using. You can do it, but for me, I wouldn't provision any infrastructure this way. It's just a way of doing it. Where it's really useful, if you're doing some CLI tools for your tooling, which is what I use it for, I use the management interfaces, and they're a bit more involved. It takes a little bit more reading and experimentation. Like I spent days on one of them just trying to work one out because I didn't understand what it was doing. But then I experimented a little bit, put it into a Go routine, and it all went to hell in a handbasket. So I had to start again. So just be careful with that. But the nice thing about this too, this is all running in Visual Studio Code, so it's got pretty good support for autocomplete and everything like that. Just make sure all the tooling's there. And I will show you a task file too, really quick. So you just go, task lint, something like that, and it runs linting. Now that's not really that exciting. Whoopie-doo, you're thinking. So what you can do is you go to a YAML file called taskfile.yaml. Get rid of this guy. I don't know about the disclaimer and all that. So what I've got here is a whole bunch of little things, and I've got a gist on how to do this. It's pretty straightforward. What this allows me to run like a mini workflow inside my build tools, so I don't have to use make files anymore. If you're still using make files, there's nothing wrong with that. Still use them if you want to. I just prefer this. And interestingly enough, this is actually written in Go as well. So you're sort of in an inception mode, using Go to call Go to build Go. It's kind of...
Wow. I tried using Cobra instead of doing this.
I have not.
And you can't have this because it has something like single tools.
Yeah.
We have to do like tons of single tools. Maybe copy and pasting them more around is a little bit tricky.
Yeah, it can be.
So in Cobra, you can actually make a library.
Yeah.
It will act as your root command,
Okay.
and it could give you all of this by default.
Yeah.
And override through properties.
Yeah.
So the need to have a task file or a main file kind of disappear.
Yeah.
And you can do that all within Go, which is
Yeah. I need to have another look. I've looked at Cobra.
Can you show us?
Can you? Yeah, show us how to do that. I've not done it. Because what I've got here too is there's a thing here where I've got dependencies. So when I run a particular job here, it says go and run these other tools first. So I run a vet check, I run a security check, I run a static tool analysis check. So when I run like build or I do a clean, then I do a build, you can tie the jobs together, like the commands together really nicely. It's not perfect. It does the job. I actually find this really useful. I used to use make files and it's nothing wrong with it. Unfortunately, this is YAML and I really don't like YAML. Who does?
Stuff like that. I try pitching this to my engineer. He literally goes, so that re-invented make files with YAML. Doesn't that sound worse?
That's what it is. That's basically what it is. I think you have to use YAML here. This is the only YAML's the future. Apparently, someone told me once. I saw someone said to me recently, XML's the way to go, and I nearly threw a chair at them. It's badness. Yeah, so you can see I've got a few commands here, go mod tidy, go mod download, go get. So that updates my dependencies. So when I'm running this on my tool chain, I can go and update all my dependencies, particularly with the Azure ones, because I don't have to go in each time and manually do it. And the good thing about this is I can put this into my CI/CD pipeline too, say Azure DevOps or GitHub Actions, and it can run all this sort of stuff as well. So it's easily transportable. I'm a platform engineer. This is the sort of stuff we do, building this sort of stuff for people. So yeah, it's pretty nice just to go generate one. But yeah, there's probably other tools that are better than this. From what I'm using it for, it's actually quite nice. That's YAML though. That's the only thing. Very good. Any questions on any of that? Put this slide up again because there's some nice resources there. Little go for. Let's have martinis. Yeah. So the key takeaways from this. Come on. Come on. So the key thing from all of this is the Go SDK is very much a first-class citizen. Now there are talks of them doing a version of the SDK with Rust as well. So watch this space. I've seen some placeholders in the documentation. They're starting to build out some of the Rust stuff. So you'll be able to do this sort of stuff in Rust as well. So can't tell you when. I don't know. Yeah. What's that? It's not a repo, it's early documentation. It's not the official one though. If you look at it, it's not official. It's put together by some engineers on a weekend using AutoMapper, so it's not official.
Even the AWS is taking up to rates and everybody is using production.
Yeah. Sorry, mate, yeah.
What's the SDK coverage at the moment? Is it like 100% or is it?
I think it's pretty. I think it's 100%. Yeah, the code coverage. I think it's about 100%. When Microsoft releases products, to their credit, they make it production ready. Like when they release something, it's ready to use. They don't sort of do it half baked. They make sure the coverage is there, because otherwise they get support calls. So if you put this in production, hey,
Do you know how the SDK was made? Was it made by hand? Was it auto generated?
a bit of both. A bit of both. They did auto mapping. They did auto generation for a lot of it, and then they went in and crafted it. You can see there's been human hands that have gone in and done it. Probably ChatGPT as well.
Yeah, ChatGPT never gotten good code.
No, yeah, man. Cool. With that, thank you. Want me to stop sharing the screen? I don't need to.
No, I took it off.
And
Thanks, Will.
5-minute break, and then come back with Gary's talk.
No.
So screen share, screen share is in class, right? Yeah.
Why?
Oh, yeah. Yeah. Yeah.
Cool. Okay.
Cool. Sharing my
Is the
screen.
banner ad supposed to be there?
What? Oh, yeah, that was kind of an idea that I had, but anyway, yeah, but no. I was meant to do it. Actually, I can do it now, can't I? No, but actually, no, it is part of it.
It's very retro.
It wasn't meant to be on this slide.
So just if you you've got the video as well.
Sweet, okay. And I guess, can we check audio? But it's okay if not.
I can see it.
Oh, yeah, sweet. Okay, cool. Like, oh, but like coming out of the device?
Yeah.
Oh, nice. Sweet. Okay, cool. Awesome. Well done. Thanks. And thanks for organizing this, by the way. Mate. Yeah, awesome. Yeah. I wonder if I can do like the presenter mode. Rehearse? Oh, you know that. Yeah. This is. Oh. Yeah. So it was kind of, oh yeah, because I said like I had this at the time when I thought of it, I was like just going through this kind of nostalgia about these old bannerers and stuff like that. Because that was like kind of weird, but that, for me that was like the first time I ever like and so then it was, yeah, and that was the community. But yeah, it's just meant to be a big push site. Yeah. Oh yeah. Yeah, well, let's see it.
This one's the one that's live streaming, or the first live stream, and then
Yeah.
second live stream. This one's the coordinator.
Oh, so annoying. I can't even remember my slides though. That's the thing. Like, I can't remember the last one, so I guess I'll just kind of wing it. Yeah. Oh, that's okay. Oh,
The secrets to the universe and life and everything is called truth. That's why
that's live, by the way.
We already started. Right. Anyway.
Okay, cool. Yeah, can't remember. Okay, sorry if I skip ahead and go back because I can't remember the whole second half of my slides, but that's okay. All right. Hey, good evening, everybody. What may surprise you, first of all, is that despite my clean cut and well-groomed appearance, I'm actually unemployed right now. So, this is a story about what's been happening in the past sort of 3 weeks, I guess, whilst I've been unemployed. Who knows what this little bunny is down in the bottom right corner? Oh, wow. Okay, cool. And then who remembers these ads? It wasn't actually that long ago, but who remembers these kind of shitty ads that yeah, okay. So since I've been unemployed and kind of looking for work sort of, or failing to anyway, one of the things that I've sort of been feeling is that, you know, when you're writing like resumes and stuff and, you know, you've got to include these buzzwords and all this sort of stuff. One of the things that it felt like was that, you know, you're there trying to like craft this kind of thing and you've got to put these things in there. But then on the other hand, there's like, I'm sure there's a lot of sort of pressure to include these kind of clickbait things. So this is the thing that I sort of emotionally, how I've been feeling the past, as I said, like 3 weeks. So, you know, a resume, like you get these things and it's like, you know, I don't know if they still have these at the bottom of these really bad articles, but I remember when they did. And, you know, it was sort of like, could this be the biggest stock of 2017? And the other ones that I really like are like, you know, when the image just has nothing to do with the actual text, right? And it sometimes feels like that, you know, like when you're reading job descriptions, it's like, okay, yeah, I can see how like these two things are kind of related, you know? And I think as a programmer and why a lot of us got into computing was because these are kind of safe, controlled environments. At least this is how I felt. And, you know, we're not sort of like, you know, we're kind of the opposite of being, let's say, like influenced by these kinds of things, right? But the thing is that you sort of see that as all right in these job descriptions, right? You know, so you hear these sort of, you know, things going on like, remember her, take a deep breath before you see Java, you know, like, I'm like, no, Java, the new Java is good, or Scala. And then I worked at a Scala shop and then, but maybe that's not cool anymore. And, you know, the unusual link between Alzheimer's and object-oriented programming, right? Because like, object, that sucks now or something. I don't know. I honestly have no idea. So that's kind of how it's been feeling. So this thing, what inspired me just very initially was 3 things, I guess. The first one was this sort of what I would call a typical after Golang Sydney Meetup conversation, which was about like synthesizers and theremins and like getting groups of people with theremins together and all this stuff. I was like, what? Like, who would speak about this? The other thing I saw was actually on Twitch, which I never went on before. And it was the lead of the Syd project, Andrew R. Kelly. And I thought, and I saw this guy and I was like, oh, this guy's like a genius, right? And he's just sitting there in front of his computer going, my God, this guy's a genius, right? But he's just still sitting there going, what's this all about? So I saw that and I thought, wow, that's kind of very inspiring, you know? And then finally, of course, I didn't want to write another job application. I couldn't bear writing more CVs. So of course I thought, hey, I'm going to start live streaming me programming. And, you know, that's a great resume. That's much better than like clickbait and all this sort of stuff. So this is the, I think, actually, this was the second day. So the thing that I chose to stream about, which is very boring compared to what we just had our talk on, which was like cloud and... yeah, I do. We'll get to that. Yeah. So this was the second day. I chose something very boring, which is SCSI 35. So if anybody's in or worked in broadcast or live streaming or anything, basically it's this binary message format that's used to signal, let's say, breaks to video players or like video equipment. And it's very boring and has a lot of old stuff in it that is not relevant anymore because it was made in 2001, mainly for cable set-top boxes. For some reason, I chose that because the last project I worked on, I didn't like using a package from Comcast in Go. So I decided, okay, I'm going to write my own one live. And so I just chose that.
All right.
I don't know if you can hear that.
Hey, nobody. So we're back again, working on some lower level video streaming protocol stuff in Go. Okay, that was the first thing. Microphone didn't work. The thing is that after like 1 or 2 days, I actually lost the first day because I didn't even bother like recording it, and I didn't know, I'd never actually watched a Twitch stream before. Why were there 3 people watching? I couldn't believe it. I think there were, I was like, Jesus. And you know, like I think, you know, I've never been very popular. You know, you just kind of stick to your computer and your weird stuff, and you're kind of very happy like that. I think there's 2 reasons. The first reason that people are watching is because I think that who here has ever used Go without using HTTP? Some people, okay, yeah, because normally, you know, you say, it's all APIs under the hood, right? But API, I mean, to me, I'm like, oh no, HTTP API with some serialization, deserialization. Okay, that's what I'm thinking. But I think that seeing Go in a context where it was just like 0s and 1s, and it was, you know, there's no sort of, you know, YAML versus JSON versus TOML versus, to me, I'm like, okay, well, they're all kind of the same. Like, you know, I don't know. Like, but so I think seeing that was kind of interesting. And why it's different is I think because, I think why people were interested is because it reminded me of a manager at one of the TV stations I worked at. And he said, we're a technology company, not a software company. So in these sorts of environments, right, like you've got stuff that's really old and the software really sucks, but it mostly works. But if it doesn't, they've got like 3 backups of exactly the same thing, bare metal stuff, and it's awful in the sense that, you know, your software mind is like, oh my God, like this actually sucks. But the technology is kind of interesting because it's low latency. It's kind of tickles that kind of bit of your brain maybe when you're even younger, when maybe, I don't know, if we were like taking apart electronics or something like that. Tickles that bit of your brain. So I think that thing's going on in the broadcast space. The translation of what this my manager was saying, I think, was I care about bits, bytes, bandwidth, and buffering. Don't talk to me about JavaScript dependencies being out of date. As long as Chrome loads it okay, just move on. And then I thought to myself, okay, yeah, well, that's fine. It's just that JavaScript, like, it's running on the server, but oh yeah, no, okay, looks good. Let's just move on. Never knew JavaScript ran on the server. So my favorite time to talk about how Go works, at least how it worked well in the broadcast space for me, versus a almost exactly the same project, was me and my friend. I wrote mainly most of the back end in Go for one project. And then my other friend, he wrote basically the same application in JavaScript. So the fonts are all stuffed up, but that's okay. We don't need more space, right? So basically, the crux of the thing was, I'm not going to stand there, was that, what were we doing here? We were reading from a very bad, this did actually use HTTP for one bit, from a very, very bad service that would use long get things if you sort of, before WebSockets and before server center vets. Is that what it's called? Yeah. And so you basically just you just keep your TCP connection open, and it's just going to keep slowly sending you bytes. And then if something goes wrong, you ask the GET request again. Now, of course, there was actually all sorts of other crazy flakiness, but it didn't matter because we had a couple of concurrent processes running. They communicate between each other. So the receiver didn't care. It didn't even know about HTTP. It was just getting stuff over the channel. That worked really, really, really well. I actually left to the Netherlands for 2 years, came back, and the thing was still running after 2 years. The server, of course, was also still up. It was just running on like some Debian virtual machine. Okay, so I thought that was pretty interesting, and it kind of works well in that kind of the technology space, not so much software-wise. It's like, well, like, don't you need to update it in security and like, what if things change and trends and, resume development, all this sort of stuff? Now, in the Node.js land, exactly the same application, spoke to the same service. This sort of thing happened, and eventually my friend left, which I was very sad about. So I was kind of left to work and update this thing because we needed it to be updated because I was moving it to a new physical data center. So the usual sort of, I guess if anybody's done JavaScript development, it's sort of this usual stuff. Go, oh, my HTTP request library is deprecated. Why? I didn't even know there was like a package we had to import for that. Like, what? Okay. And so then you need to choose one. And then this websites have got like logos and stuff for HTTP library, and you're like, well, I don't know, like which one do I choose? So I chose that one because the logo seemed okay. But then actually the new version Node was coming out, and that actually had an HTTP sort of client library in the standard, in the standard distribution. That was pretty cool. So the other thing that I needed, especially because I was like, I'm not a very good programmer, and there were no tests. I needed tests to like understand what the thing was doing. Again, which testing framework do you want to choose, right? This is what it's like in JavaScript. There was one from called Jest, which was really big, used in developed by Meetup. As I said, really big. It itself pulled in like a shitload of dependencies. There was one called Tape, which was really small. But again, it was like, oh, like Node has new one built in. But then, oh, wasn't that test runner? I think it was like alpha or beta or experimental. I think there were like 3 categories of stuff, and I couldn't remember which one was which. So then, of course, you go on to like Docker and Kubernetes, and then you're like, oh, okay, but like what? Because you don't know what maybe the Linux distributor is going to get you in your packages, right? So you're going to enter into this kind of world of stuff and thinking. And so then, what do? I was there and I thought, shit, okay, this is going to take a little bit longer than I thought. So I went to my manager and he said this. And I was like, damn, okay. So I can't remember what I wanted to say after that. Yeah, anyway, so that was kind of where I was at. I had this experience in maybe more technology land, not so much software land. And yet people were watching. There were 3 people watching. So a few days went by. A couple of people were other watching. A couple of other people were watching. And in these live streaming things, you've got chat to the side and you're kind of there like saying at the camera for like 5 hours. And a few people started saying this sort of thing. Oh, yeah, that's right. Yeah, that's where I got that from. Exactly. Yeah, so I was getting these things, and one of the messages that really got to me was this, oh, no way, it's the guy from the meme. And I was like, what meme? Like, I'm not really a meme kind of person. I don't know, like my girlfriend loves them. I don't know, like, and I love to see them from her. But I don't really know about that. Like, okay, whatever. I'm just still working away on like bit packing, and all this sort of stuff, trying to save some bits. And then somebody sent this to me. So they said, dude, you're blowing up on Twitter and YouTube right now. And I was like, well, what Twitter? Like, I don't even know whether tech people use Twitter anymore. Like, doesn't it suck or something? I don't know. And YouTube. Okay, well, I only started streaming to YouTube the day before or something. So what was going on? The first thing that actually came to my head was, damn, I had these emotional thoughts of like, God, it's like applying for the job. It's like doing this resume stuff. Oh my God, it's torture. Where you're trying to write this stuff where it's like, with the hard bit wasn't really the programming, but I've got these clickbait things maybe. And yet, that like when people submit all these resumes, I guess, I don't actually know, but it feels like there's this sort of pressure to kind of like, stand out from the crowd where all this other stuff around you is going on. Eventually though, I did have a look at the Twitter things and, oh wow, actually, oh wow, Jesus, yeah, okay, I didn't know that I could do that online. Okay, so this was one of the tweets. I eventually looked and yeah, and it got like 200,000 views or something. And initially I was like, what the hell? Like, and then I read the thing, I'm convinced that devs who use Acme are just a different species. I was like, what? Like, so Acme is this text editor on the left. So yellow background. Text editor kind of, yeah. 2 days later, the same thing started coming and like the YouTube thing was going crazy and like you're getting lots of messages and stuff. This one got like 400,000 views. And I was like, what the fuck? I'm just sitting there in my apartment. Like, I can't tell you how bizarre this is. I don't know what's going on, infracritical, no, not really. Like, it's just ad breaks. It's to make money. Like, it's not really a big deal. So I was new syntax highlighting. Yeah, I don't know. Like, I just never got around to it. Like, use VI on a Unix box. Like, you don't have it. Uses 25-year-old code editor. It's like 35, 40, I think. I don't know. Wears sunglasses. Yeah, well, Well, listen, mate. As an influencer, you've got to stand out, Yeah, I know No, generally, no. Actually, I have. That's right. Yeah. No, I actually take an injection. I get very sensitive eyes. So that's actually the reason, which is really funny because people thought, yeah. And then sometimes works 9 hours straight, no BS. Yeah, but people work like super hard. I don't know. People work many hours longer. So anyway, that's what happened. Now today, still doing it. So I had like I did like a couple hours before I came today and then didn't realize the time. So I had to run off. But it's a really nice thing to do, I think. I think that it's one of these things where you're sharing what you're doing, you're showing what you're up to. It's it's easy to read. This is the thing, right? So it's not like, you watch other people doing other stuff, and sometimes I found it quite hard to read. And as I said, there's now, at least there was like 20 people at once watching, which I was like, like this is about the size of the room or something, I guess. It's just super weird for me. Why were they doing that? Okay. Same reason, right? Tech, seeing Go in a different context. No HTTP, no web, just some other thing altogether. There was that going on. Okay, every time you go online, right? You're there, you start, and then a new person comes in and they say, oh, what is that IDE? And then there's all these other questions. And it's like, what? Like, what's the big deal? So of course, maybe the second reason people were tuning in was actually the text editor. So I'm the kind of thing is like, no, the tools don't matter, right? But I think we all love to like nerd out about tools and stuff like that. So what did I want to say next? Yeah, so that's a link to the paper about this particular editor. I can't give a live demo because this is not my computer. However, Russ Cox, who we may have heard of here, he did a really cool video just doing like a live demo of the editor and kind of showing it off. I'll highly recommend watching that. But why I want to talk about Acme is actually, the thing I want to bring up about Acme is that if I just go back to here, so you got Windows, right? So you've got 1, 2, 3 windows, and you've just got these text buffers. So pretty simple. They open up files. So each of these is 3 files. One's a directory in the top right. One of the unusual things about Acme that's relevant to Go, I think, which is a little bit unexplored, is how Acme presents itself also as a file system. So this same, go back to here, 3 windows, 2, 3, 4. Those are 3 windows, they're directories. And within a directory, you've got the address, which is where the cursor is. So see, we've got 3 cursors in there. So if you choose one of the windows, you've got the cursor at address 3. Was it index for 0, index for 1? I can't remember. But anyway, it's there. So that's pretty cool. Now we know that Go and sort of the history of it is, we've got some great I/O libraries, right? Like we've got things like I/O Reader, I/O Writer, super simple. The implicit satisfaction of the interfaces is, very handy. It's very pipe-like, right? So in the same way that you can just read and write these pipes, you can also, use it in Go. And indeed, that is how you can write programs to be used from Acme. And normally you edit text, right? You open files, read a file, write a file. But what if the things that are files are not actually bytes on disk, in a block on an actual like physical thing? What if there's something else altogether? For example, I wrote this, this package here, which uses the IOFS package, if anybody's used that or heard of it. Yeah, so super cool, right? I don't recommend using this particular Fediverse service because it's super weird, but it was just an interesting experiment to use IOFS. The idea here is that we can generate a synthetic file system, that could be used from Fuse or something. So for example, we've got a directory called, let's say, a group called golang-syd, and then inside of that, we've got numbered posts. So this can apply to pretty much anything, right? You have a Twitter handle, and then post number 1, 2, 3, 4. Because Acme presents itself as a file system, writing plugins for Acme, they're not really plugins, right? They're just writing bytes to standard input, standard output. They're reading files, writing files, super easy. So this is apparently a demo. I don't remember doing this, but anyway. Oh yeah, so this is actually the thing working. So normally you're editing files, but in this you can actually This is browsing. It's just like Reddit, but for something else. So here I'm opening a group, like a subreddit, and then I'm browsing to a post, and then you've got the post there. So this, if you read the code or have a look at it, it's super simple, right? Like it's just, you know, we're reading and writing trees of files, and because in the top left of each Acme window, you've got,
Hey.
how did I knew you'd pop that, but I did that for you, mate. I knew you'd pick that up. Yeah, that's it. Yeah, so that's one thing. That's browsing something. But you can also do more interesting things. So for example, here is, what's this demo? This is accessing GitHub issues from Acme. So you can have your files there, and this shows off a few bits and pieces about Acme, and also a little bit about the how Go fits in, which I guess I could talk about more. I don't know how I'm going for time or something, but I tried to keep it short. So here I'm opening an issue in the project that we're working on. I'm writing a comment here, so I'm just writing somewhere in the file, doesn't matter. And this is another trick. So I've done number 9, right? So, oh wait, what am I going to do now? Okay, so I'm just writing some code. What I want to do is I want to indent it. So I just write some text in the interface somewhere, doesn't matter where, it's all just text. You can execute it, load it. So I just loaded number 9 by right-clicking it. You can load, execute, or select text. And it doesn't know what it is, and you yourself control what the actual, what happens when you either load or execute stuff. So right, I just executed which, A+, and then I open the file by right-clicking it, and then you can see that the actual plugin for Acme to indent text is literally just a sed, like a raw sed script that just, you know, replaces the beginning of the line with a literal tab. Does it? And there's the thing working. So there's the, yep, there's the code that does it. So Go's way of,
You have to know like the endpoints, the GitHub endpoints.
yeah. So in that one, it's actually like hard coded.
Okay.
Yeah. So yeah, in that one, yeah. But normally, I mean, it's just so that issue command I ran.
Yeah.
You can just run that on the command line.
Yeah. Yeah.
So all that thing is doing is just writing to go back, just writing to these particular things.
Mm-hmm.
Yeah. So I don't know what else I was going to say. Oh no, I guess that's it. Okay. Yeah. Well. I mean, I could go into more detail, but basically, yeah. So what was the one weird trick editor, right? Well, it was sort of Acme, right? Like in a sense, because what happens is that people see the yellow background in Twitch and they go, what the hell? Like, why isn't it using dark mode, right? Like, why is it so weird? What is it? So was it really the Acme editor that actually got the thing going? Maybe. I think it was actually Go's, you know, sort of seeing Go in an unusual context. And I think another thing, the main reason, the deep reason why I really wanted to do this sort of thing is really just as a way to, did I have a slide about this? No, I didn't, but whatever. It was really about to, you know, come back to the web ads and how maybe some other people got into computing, which is, you know, you're there, like, you know, in your sort of controlled environment, and you want to share what you're working on because, you know, it's not that well known to so many people. So live streaming about it, I'm not saying live streaming is the best format for this, but I think we all learn a lot from open source stuff, from sharing stuff, and it's been a really nice way to give back. And people are also now writing to me, which is super nice. And here we are talking about it. So I encourage anybody who, even if it's not cool and like web dev, to share about it. And like, just, you know, there's people all over the world, I think, watching now. So I think, yeah, I think that's it. Any questions or whatever is, yeah. Yeah.
Have you tried VTuber software? So it's a VTuber software.
Oh, the ones who did, who are maintaining Inferno now?
VTuber is basically a thing that like a camera.
thing that changes you into an anime girl.
Oh, yeah.
Anime chicks on YouTube who are coding low level stuff.
Yeah,
And they get lots of views.
I've seen this. Yeah, I'm not, yeah, like I'm watching this stuff and I'm like,
Second channel.
yeah. Yeah, I mean, the way that these streams are put together is like very, yeah, you know, some subscriptions, I have some fans, you know, with certain prefixes, fans.
So how can I donate to your stream? Because there's a link on it. And it's usually a link.
Was it? Oh, yeah. Oh, yeah, oh, yeah, there you go. See, very prominent. Yeah. Yeah. I'm very happy to have no ads on the thing because, you know, nobody likes ads.
Yeah.
Yeah. It's sorry, very badly small there, but you know, it's not really. I mean, it's only there to pay for the VM that we're using to try and self-host this thing. So we're writing. If anyone's interested in video stuff, we're doing a bunch of like, you know, raw. We're writing raw over UDP to write directly HLS stream, and yeah. So there's a $5 VM somewhere that needs funding. So. Sorry.
Is the first editor I used. That was one of the boxes that I was walking into back when I was a kid. Why
So the thing before Acme was a editor called Sam, and Sam is yeah. So and Sam is kind of like ED. Yeah, but that would be, I mean, yeah, it would be so cool if like that got the same thing as Java, right? I mean, if anybody's interested in that, yeah, there's a lot like those. Yeah.
Taking a break, or do you want to go straight in?
I think let's just go straight in.
Yeah.
You got no camera.
Sorry?
You enable your camera?
Camera's enabled.
Sure.
You sure?
Nope. Okay, it's enabled now.
Okay. Katie called last week and said host, and we actually were trying to host one here a little while ago and it didn't work. And so I said, yeah. And I went, well, I'm actually kind of knee deep in some kind of interesting Go code at the moment. So I said, well, yeah, I'll do this. I said, let me present. And there's like, ADL is a little data modeling language, kind of protobuf-esque, except more usable from a human point of view. It's something that got written by one of the Helix engineers, actually before he started Helix. When I started here, I went, then I knew they weren't using protobuf, and I was kind of going to come in, yeah, they're going to use protobuf. And I got here, and it's like I've learned a shitload from Tim about algebraic data languages, just effectively the algebra of naming things. One of the things that I've started doing this is, I think, the fourth time I started. The first two times I started Go didn't have generics, so it didn't go anywhere. But so this is not about ADL. This is really about Go. So I thought let's do a kind of a choose your own adventure talk. So like this involves audience participation. If not, I'm going to be choosing. Okay. So look, a really, really brief primer about ADL. So this is a little piece of ADL I wrote for this. So ADL's got declarations. It's got 4 declarations: product types, sum types, type aliasing, and type aliasing with the new type. And it's got a bunch of primitives, right? It's a really small language, right? It's got generics. These no restrictions on the generics. There's no co or contravariance on them. They just are almost macro substitutions. It's got annotations. So you can take any, and these kind of annotations are type safe. So it's like a comment that's type safe. So you take any decal that you've defined previously, and you can use it to decorate. You can use it to decorate decals, fields, etc. Very similar to protobufs, extend, and options, except the blessing of them is implicit. There's no extend keyword. There's only options, right? And importantly, it's got default values, which apparently Proto has, but no one can figure out how to use. Okay, so this is the first choice of choose your own adventure. Are we going to talk about the representation of those in Go? Or are we going to talk about bootstrapping or code generation? So hands up for Go representations. Hands up for bootstrapping. Hands up for code generation. Okay, so Go representations win. So in ADL, you can say type page equals string, right? And that's equivalent in Go. No, so this is, okay, so let's just back up. What I've done is I've written a code generator that will take ADL and generate Go code, right? In order to do this, you also need a little bit of a runtime. So you need some stuff that supports, mostly it supports things like encoding and decoding it. It supports registering of the meta information so you can get it at runtime. This is pretty straightforward, right? If you see type page equals string, it's going to be type page equals string. And we're just changing the case because in ADL, a primitive begins with an uppercase and Go, it's a lowercase, right? You can say new type, right? And that's the same, except there's no equals in Go, right? And so the difference between these, the difference between these two in Go is that a page is a string, whereas if you just said if you just said type page string in Go, then you'd have to unwrap and wrap it. You'd have to do conversions, right? A struct is a struct, and then in ADL you can say union, and this particular thing maybe is actually part of this the ADL standard library if you wanted. It comes there. So you said I've got a maybe T, and then I've got 2 branches: void, which has got a name nothing, or T, which or just, which is a type T. Void's badly named. It's basically the unit type. So think struct, open paren, close paren, open bracket, close bracket. It's the unit type. If you ever use struct open close in Go, and then you make an array of 1 million of them, it uses 0 bytes. So it uses the bytes for the allocation of the array. They use no space at all. Okay. So choose your own adventure. You're going to hear about sum types next. Okay. So how are we going to implement a sum type in Go, right? I think it's probably after generics, like the top listed issue that Go doesn't have sum types. Now when you're writing a code generator like this, now ADL itself is represented in ADL, right? So when you're writing a code generator like this, the very first thing you're going to do is you're going to take the ADL AST and you're going to implement that in Go so that you can. By the way, I didn't write the parser part. There's a Haskell code base that does the initial ADL toolset is in Haskell. Later stuff has been in TypeScript. We've been rewriting it in Rust. So I didn't rewrite the parser. What's happening is the Haskell code is taking the source ADL code and producing a JSON format of the AST. So what I needed to do first off was to handwrite Go code that represented the AST, not particularly big. And this is the maybe that I wrote for it, right? So maybe T, and then you've got 2 pointers. You got a pointer to a struct curly curly, and you've got a pointer to a T. Well, one of them is going to be filled up. And so when you handwrite this code, you write your marshal and unmarshal, right? So that's version 2. There was no version 1. So version 2 is the hand-coded one. Version 3 is the one that generates itself, that bootstraps.
So you mentioned the front end in Pascal.
Yep.
Does it generate like an JSON or does it generate like a different type of ILR?
No, just JSON. So
It serializes JSON.
it serializes JSON.
Yeah.
So ADL serialization on the YS bit format is JSON,
Yeah.
right? It's kind of irrelevant, but its value format at this point in time is JSON. It's isomorphic to ADL is almost isomorphic to protobuf. And one of the implementations, I think the second one I tried was actually just to say, well, actually, let me just convert everything into field declarations in protobuf and then use the protobuf toolchain. It actually worked, but it just like it wasn't particularly satisfying. This has been the most satisfying of the implementations that I've tried. Okay, so the version 3 one, which is the one I generated, uses the same thing that protobuf uses, right? So you have a struct. The struct contains an interface. The interface is implemented by your branches by a private signature, so it's closed, and then okay, and that's it. It's implemented, right? The problem with these things is they're not very usable. Whenever you're constructing these things, like they become just like you're in the middle. I just want to construct one of these unions, and you've got these wrappers and blah blah blah. So we'll deal with that, right? Okay. So another choice. Are we going to look at exhaustive? Because that's not the only code I generate for unions, right? So I generate code that allows you to do exhaustive switching. And one of the things that I really want is I want the code to be friendly. I want the code to be friendly. So hands up for friendly Go. Hands up for exhaustive unions. Okay, friendly Go it is. It was close. It was close. Someone else can do the counting if you don't trust me. Okay, so so what do I want from this? Well, I want type safety always, right? So when you make a struct, like there's two ways of initializing a struct. You can initialize a struct with names. You add a new field to that struct. The compiler's not going to complain. You may have wanted that field, right? I want things to blow up so that I have to go and fix it. The other way you can implement a struct don't use the names. The compiler will then enforce that you use every single field. But ADL's got default values, right? So I wanted to force me to fill in the values for things that weren't defaulted, but not the other way around, right? Also, exhaustive handling of branch unions. I add a new branch to a union. I want the compiler to blow up until I go and handle that branch. Okay. Now, I've had a number of debates with Go authors about this, and they actually think that exhaustive switching is a really bad idea. I have no idea why. I mean, Russ, Rob's a really smart guy. I don't understand why he wouldn't want it.
You can't evolve the code.
Yes, you can.
That's the answer.
Okay. The worst case is that you do evolve the code and it doesn't break and it breaks at runtime, right? It's even worse. Break at compile time, right? Okay. So who wants to look at some of the stuff around type safety on structs? That's the new and make, the first one. Okay. Who wants to look at construction of unions, friendly construction of unions? Okay, and who wants to look at leaning into Go Please to make this thing Go Please happy? Okay, so unions win. Okay, so I also generate a function per branch in the union that just does the nice union stuff for you. Because otherwise you've got to, you're in the middle of creating a struct and it's got a union field and it's just, I don't know, who protobuf people? Who's been annoyed at protobuf just can't figure out how to instantiate their type, and you literally do something like you make the default one and you print it out with %v and then you fill it in again, right? It's just horrible. Sorry, it's just horrible, right? So I'm just creating a bunch of helper functions. Now, I don't know how this should be. The other option to this is instead of putting the name of maybe, instead of putting the name of the decal in here, I could have done this all with methods with no receiver argument, right? But then it's not nice Go because you got open paren, star, star name, close paren, nil, blah, 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 call it, right? I've done a bit of that, but so what, right? And we'll see when we get to go, please. It actually makes some stuff quite nice.
So we don't actually have a choice. It's free will is an illusion.
Order is a choice.
You don't get into debate about do you actually have choice inside Helix. Like it goes down rat holes. Okay, so you don't have a choice. We're looking at exhaustive switches. Okay. So again, I generate a function. So I handle name of your union, this was quite interesting stuff because you've got to separate out between. Well, maybe he's got a type parameter, but I need a type parameter for this so that so the two type parameters. The second type parameter is what are you returning? So if I had a union that didn't have a type parameter, right, then there would only be one type parameter up here. You need the T over here because that's your return, right? ADL doesn't allow underscores for start of names. So anything that I have to discriminate between these are names coming from ADL code versus names, I just put an underscore and I know that they won't conflict, right? What it does here is it does the switch for you, right? And then it calls the function that you want, right? This is a little bit not nice. That null shouldn't have anything because there's only one thing you can pass in the entire world. I just haven't put in the case for saying if the thing is a void, just don't do anything. It's a little bit complicated because you've got to do it for field declarations, but you don't do it when you're receiving the argument. Okay.
You can do it if you have a sort of package-wide or system-wide nothing.
That was the way that I did the version 2 thing. Okay, but it's not quite idiomatic Go, right?
Okay. Maybe nothing is not idiomatic Go, just FYI.
There are a number of ways of doing this. You could create an interface, but it's really difficult you can't construct anonymous interfaces in Go. So that made the using code quite difficult, right? This is the one that I settled on. Functions can be nil. So there's a panic at the bottom. If you passed in all nils, this code has to panic. There's nothing it can do. There's nothing sensible it can do, right? So you're passing in the functions that are going to get called back, and there's a last argument, which is, look, I want a default case for this. Okay. And something a little bit nasty with Go is that it doesn't have tuples. So if you want a version that returns an error versus a version that doesn't return an error, that can't be a type parameter. So I generate 2 of these. I generate one with handle with error and one handle, right? I don't know a better way to do it. Yeah. Okay, so again, you don't have a choice. We're going to look at leaning into Go, please. Okay, so now let's say that I have a maybe value and I want to write something that handles it, right? So I type, the maybes in the package called types. So types dot h, and here are all the handlers. So I choose. I'm not particularly good at live coding, so I thought just screenshots. So you hit enter, and it says, well, okay, yeah, here's your maybe, right? Now, I don't know if you remembered, but the handler was generic. It had type parameters. So we fill in the type parameters. This is all the manual typing I did. So we fill in the type parameters, and then you give the argument. While I was doing this, I realized if I changed my code differently, I wouldn't have to do .branch. I know that all of my unions are going to have a field called branch. So actually, I started changing it, but that's for another version. It won't take long. So now, because we put the type parameters, let's just back up here. What we're saying over here is that we have a maybe. The maybe is holding a string. So the just branch of the maybe is string. And this thing, whatever it is going to return an int, right? Okay. So now we go F spacebar, or it realizes, and it says, look, function ... Now, if you use globe please much, if it says function ... it means that it's going to fill in the parameters for you. It knows what they are. If it just said function open bracket, open paren, close paren, it means I don't have type information. I know it needs a function, but I can't tell you what it is, right? Which is why we went and put in the string in the int. Okay? And so it says, oh, and it names it for you. It knows from it what it is. Null of the struct. Again, this should be empty, right? And so now we put a comma and we go function, and it says, oh, I know that, you know, just string. And now we put a comma and say nil because there's no default case, right? And now what I do is I just go and fill it in, right? And the interesting thing, I found a little bit interesting, is that you can see at the top string and ints are now grayed out, because go please is saying, actually, I can infer the string and ints from the rest of the thing that you've written. There is one of the issue trackers is to say, look, is there a nicer way of writing lambdas, right? Because if you think about it, it gets a little bit confusing, because fine, you could leave out the struct over there, but then is that in the name of the return type or the type of the return type? It just becomes a little bit of a funny case, lambdas. So I now have code that has all these gray things that if you hover over them, they're going to say, look, you could have done something. You don't need that. I don't care. Like, you know, yeah, typing. There you go. An unnecessary type argument. Okay, so there are some, not issues, there are some, I've said issues with go please, or we can talk about CodeGen. Issues with go please. Hands. CodeGen. Okay, fine. Okay, so what? Rust macros. Yeah. So one of the things that would be a nice thought with ADL is actually have a Rust macro that you can put ADL in directly, and it would be a type macro that returns you types, like it does with ABIs. So it's something that we're looking at. My Rust is not that good. I borrowed quite heavily. I looked around. I've looked around a lot. I've done quite a lot of CodeGen. Most CodeGen is print line. Rust, there's a CodeGen. There's quite a nice CodeGen thing, but it requires you to use nightly because otherwise Rust macros. So Rust macros aren't white space sensitive. They don't know the white space that's in the macro by default. There is a nightly that does it, but then all my Rust codes are nightly and it breaks every time they do some nightly update. The one that I'll end up using for this is borrowed from Captain Proto. So it's template-ish. And there are a couple of nice tricks that I got from it. One of the nice tricks that I got from it is that the payload that you pass in a pointer, in this case, a pointer to generator. And if you go and hover over generator, this is what go please says you have. So you're not using the function params in templating. What you're doing is you're passing it. I have some function params, but what you're doing is you're passing in an object that's got method calls on it that can be called in your template. And it's a really nice balance between really ugly templating. One of the things that I want with this is that I would like over time to migrate, particularly the CodeGen that we've written in TypeScript, I'd like to migrate it to Go. And so what I want to do is I want my templates to do the language specific stuff. I don't want to have to do the language specific stuff before I give my data to the templates. Otherwise, I'm kind of making it a bit rigid and making it difficult for other language code generators. So this is a neat trick. The other trick another trick that I picked up from them is that here are the names of all my templates, right? For every name of a template, I have a struct in Go that's exactly the same name with the word params after it. And then what your renderer does is it just uses reflection to get the name of the struct of the variable, strips off params, and then finds a template with that and calls it, right? It's okay. It's a neat little trick, right? There is a shitload of reflection code in this, right? It's not dodgy. It's not, why is it dodgy?
Okay, this is go on.
I don't think it's.
Okay, so here's an example. Right? So we're ranging over a thing called fields. So fields is something from the ADL AST, and we've got G dot go type. The reason we've got dollar is because we're inside a range. So earlier I put aside G, no $G. So G dot go type, and go type's implemented. You give it a type parameter, and it'll give you back a string which represents the Go version of that ADL type, right? Nice little trick is that templating swallows panics, right? So it swallows a lot of stuff. So if you're inside a template and you throw a panic because you want to know the line at where your code is messing up, you're not going to see it outside the template. So just put a panic, just put a deferred recover inside your template, inside the calls that have been called by the template, so that you can print out a stacks.debug, right? You can print out a stack trace.
Yeah, that's good.
Mark, you're smirking.
Very complicated.
This is complete. Look, this is highly recursive code, right? Here's an example of the template okay. This is great. This makes me smile, right? Okay. Bootstrapping encoding or AST registration? Bootstrapping.
Yeah.
Bootstrapping. Encode, decode. AST registration. Okay. I don't have an answer. Who choose? Huh? Okay, AST registration. So one of the things that is really difficult in Proto is getting the option information back at runtime, right? I don't know if anyone's ever tried it, but like literally you squirrel that code away and just so you can go back and find it. It's just mind-numbingly so I wanted to make I wanted to make this easier. So for every decal, I give a function called type expression underscore, so t expression underscore, and basically that is the name that you can use. Okay, so that's the one thing. And the second thing I do is I write out the declaration, the full decal, again as a function, and then I've got an init that globally registers these, right? What I would like is a nicer way that I don't have to globally register stuff. Yeah, so what it means is that at runtime, you can actually go and get this information, right? And so one of the pieces of information that you can go and get is, in the example, I said, look, we've got these things called annotations, right? And so the annotation is put away into the declaration, into the decal. Now, here, and by the way, even though it says any, so my annotation, I'm not talking about custom types. There's custom. You can specify custom types, but I'm not talking about that. Yeah. So it's a scope. It's a map of a scope name to an any, right? Even though it's a scope name to an any, we know that that is type safe. We actually know the type that's there, and so there's some helper in the runtime that you can say, give me back a particular annotation, and it'll actually decode it for you and give it back to you type safe.
So if you already know the type generation intent, why don't you just put it like that?
Because in the AST that could be any the.
Oh right, okay, I get it.
We know it. We can't tell that. Yeah. We can't tell the AST what it is, because the AST has to be able to hold any of them. Yeah. Right? And so this is a lot nicer than trying to get option information back from Proto. Okay. Encode, decode. No one was particularly keen about. Sorry, this is just Google Slides with link buttons in it. Encode, decode. So we can do a lot of really nice type safe stuff, right? So we can make encoders and decoders that are totally type safe, right? Someone needs to show me. I think there's a trick where you can specify a type parameter where the thing you give it is either a pointer or the thing itself. I don't know how to write that little piece of magic. Encode, you have to give it a pointer. Decode, no. Encode, you can give it a pointer or a value. Decode, you have to give it a pointer. right? There's a bunch of helper stuff that I need to generate. So here's an example of a method that I generate that doesn't have a receiver value. It's just got the type, because you need to be able to, at runtime, I went through all the issue trackers and I went through reflection. There is no way to construct a totally dynamic generic. You have to know the generic, even though it should be possible. You could, there's two methods to get a type. There's reflection.typeof and reflection.type4. You almost need one that's reflection.type something that's actually got types as arguments to it, so that you can construct a dynamic one. There's no way to do it. You have to have one to make one.
You can have one, and then you just replace a string inside the name of the name.
You could mess with type, I guess, but no, thank you. No, thank you.
Like a type select, like, so you give it a subset of would be possibly this type.
No. You only want one. It's not polymorphic anymore. It's monomorphic. But there's no way to construct one of those. If you've got an array of types and the container type, there's just no way to construct that. So instead, what you do is, in this particular case, is you return the 0 type so that you can reflect on it and then go reflect.new, right? That could have been reflect.type of, or reflect.type4, right? Okay, so we're going to go to bootstrapping. Okay, so we're using ADLC written in Haskell to read ADL source and produce a JSON representation of the ADL AST. Sorry, I'm reading slides. This is not bootstrapping. Okay, that's not a definition of bootstrapping. Okay, we hand code an AST in Go so that we can take the JSON and deserialize it. That was version 2. We then write a version 2 piece of Go code that reads the AST and spits out an AST. Spits out AST version 3. When we're happy with that, we then copy and paste the version 2 folder, call it version 3, go and replace all the imports to version 3, fix up all the type, all the squiggles, and then we run version 3 to take version 3's AST and produce version 3's AST. Now, 2 repos. One repo for the compiled code, for the generator, one repo for the runtime and generated code. Lots of git reset hardhead, right? We delete version 2 and we version tag it with everything and we push it, right? And then we continually make changes to the version 3 to generate version 3, fixing up the type errors, fixing up the errors on the way. So you've got something that can generate. Now this is classic compiler writing where I think Richie's words were, you're teaching the compiler new things. And in the example he gives in Trusting on Trust is he gives the example of how you teach the C compiler new escape characters, right? Same sort of trick. Interesting code, right? And it really gets hairy when you start to have custom like structs and unions, trivial. Structs, unions, params, generics, yeah, okay. Generics mixed with default values and custom decoders, holy moly. Yeah, and this is a simple language to implement, right? And I'm not doing any of the type checking or anything like that. That's all been done.
Not the simplest.
What?
They're not the simplest. They're simple languages are like lambda calculus.
You know types. Simplest type language. This is only about types.
Yeah, it's like lambda calculus.
I used workspaces to do this. There's some nasty-ish bits between workspaces and when you want to start to version things and go get. When you're doing go gets on things that are in a workspace, but you've pushed a tag, it gives you weird, like you've got it wrong, but the errors are weird. So I've got a repo, Go ADL. That's got 3 sub repos, Go ADLC, the runtime, and the tests. And each of those are submodules. So I've got, I think submodules, don't look at me about submodules. Trees are worse. Okay. GoGen and subtypes. We look like we've got into a loop. So let's just jump over here and jump over here. And that is the map of Choose Your Own Adventure. And I'm not sure if you'll notice, but there's a really, really tight loop between bootstrapping and CodeGen. Fancy that. Yep.
What's the other little one that's on its own underneath CodeGen?
Encode, decode. Oh,
No, a tiny little one.
Oh, and that's this page.
Oh, okay, that's where we are.
That's where we are. X marks the spot. Where we go, that's an exercise for the reader. Cool.
Is this done in ADL?
No, that was Mermaid.
To generate a mermaid, do you use ADL?
I've got a generator written TypeScript that generates class diagrams from ADL. But I don't have one that generates sequence state diagrams because that's a different project altogether.
You started with ADL of this page one.
Okay, so we'll go back to the beginning. There we go. Okay. Yeah. So look, as I said, this is not a sales pitch for ADL. But as far as a number of you know, I've been thinking and looking and playing with like really deep stuff in what computation actually is. And this is one of the lowest useful forms of computation.
I really don't want to ask this question. Was this
Then what?
was this for work or was this just for hobby?
Both.
Okay, no los dos.
Your sort of like idea of union types there.
Yes.
I'm guessing that you have spoken to the like GoDev team.
No.
And okay, are you thinking of putting together a proposition and saying?
You know how many propositions there are on union types in the issue tracker?
Yeah.
There's only one that's taking off though.
It would be nice. Look,
because personally, I don't care if they're syntactic sugar. I really don't.
you could just, well, this is syntactic sugar, right? Look, interfaces now mean two things. They can either mean contracts or interfaces. People would argue, constraints. People would argue that why do you need them? You've got type switches. When you've programmed in languages that do have exhaustive switches, I'm highly dyslexic. Anything more than about 10 lines of JavaScript makes me cry. I really like my compile errors.
That's just JavaScript.
No. So yeah. Look, TypeScript makes it better, but NPM still makes me cry. Yeah. So no, I don't. At the end of the day, it kind of is syntactic sugar.
And to that point, the man, the baby. Just on that question, have you considered looking at what a variant of this could look like for you to modify the Go tool chain to actually support this? Like you can
So if I could wave a magic wand, I would explode languages so that you've got a separation of concerns. A language that is Lambda equivalent, I would say don't allow it to define types at all. It can only use types defined in a language that is specifically made for defining types, right? When you start to look at these things, Q, for instance, it's got annotations, but they're not typesafe. It doesn't have discriminated unions, but you have to effectively put some version of the unification engine into your head, which you can't actually do because Chewy tells me that it actually pulls in library functions to determine the unification. So there's no way. Huh?
Most of the time you don't do
Sure. So even though the unification engine in Q is like it's a backwards forward propagator type thing, I think you cannot humanly put that into your head. So if I was to say something, the Go tool chain, no, let's do something like having, instead of having a single language that rules them all, we need a soul. We need a system of languages where you've got high coupling, where you've got low coupling and high cohesion between a family of languages. And ADL, there's changes I want to make to ADL. Its heritage syntactically is Java-esque. The way it does imports, I'd much prefer to do Go import style. There's all sorts of things, but this is a journey. The higher the mountain you want to climb, the more circuitous the route. This is the first step, totally orthogonal to the mountain I want to climb. Looks like it, but there are reasons why I want some clay that I can play with nicely.
Oh, I was going to say, there's an ADL package on ADL project on GitHub, which does Rust and
Not this ADL.
isn't it? Oh, okay.
Sorry.
GitHub video, and it generates code in Rust.
Yeah, so it
Go to that.
this is Helix. Yeah, I don't particularly like the mono repo approach to language generation personally, which is why I've done it outside of this.
It's can't remember the ADL.
Not ADL dash ADL, just ADL. Maybe.
No idea. Not sure if it's the one that stands for algebraic data types, but ADL right now, yeah, it generates Rust. In fact, we've got 2 implementations of it that generate Rust, one in Haskell and one in Rust.
It generates JavaScript.
It generates TypeScript, not JavaScript.
Java.
And
Java, Haskell, C++, Rust, TypeScript,
Yeah.
and soon Go.
there was an issue in this, and I said, I should generate Go as well. So
Might have been me.
Okay, I think we can maybe wrap it up. If there's any more questions, perhaps we can wrap Gary after. But yeah, thank you very much.
It is me. Right, thank you, people. And on live stream, thank you for joining us.
I was going to say, actually, Gary, if you wanted to share with everybody what this actually is, because a few people have asked me, and I've been telling them